Hello, everyone. My name is Jia Kim, and I'm one of the fellows of University Design Research Fellowship Program of the 2020-2021 Exhibit Columbus. In this presentation, I'd like to briefly review our collaborative process through the design, fabrication, and installation stages of our work, LaWaSo ground, located at the lawn of the First Christian Church. Many parties and individuals contributed throughout the process, and we immensely appreciate their involvement in the work. The presentation is organized based on the design, fabrication, and installation sequence. In addition to our core design team, including my partner, Dorian Bybee, and our students, Titan and Brian of the Ashkenazi J. Irwin Miller Architecture Program, many community members of indigenous nations of Indiana were involved in multiple conversations during the early to mid design stages, and we truly appreciate their feedback and support on this project. Especially Katrina Mitten, an award-winning Miami bead artist, was involved throughout the design stages to signify the motif pattern of water daram and also the symbolic ribbon patterns of the four nations of Miami, Kickapoo, Potawatomi, Delaware, and Shawnee. These patterns were engraved on the limestone panels where the two different landforms intersect in our installation. Many community partners and sponsors were involved throughout the fabrication and installation process. For the most part, I will note individuals and groups more specifically in the following sections. But before going into that detail, I'd like to express our gratitude to Rick Herman, the site's representative of First Christian Church, who supported us so much to set up the site during the installation stage. And I would like to thank you so much, Rick. We started our fabrication process with the basic ground structure of the landform. Most of the structure were fabricated using our in-house equipment in the shop of a J. Irwin Miller Architecture Program in the Republic Building in Columbus. We're especially thankful for Steve Baker, the manager of the shop facility, to help us to run all the equipment and machines so smoothly. We utilize a simple egg crate waffle structure system to support limestone and also to define the shape of the turf mount form. All the pieces were assembled within the size that can be cut on our CNC machine. And also they were all tagged and labeled to be assembled and also to be located on the site properly. More than 45 sheets of 4x8 plywood sheets were used for the construction of the base structure, and about 28 sheets were routed on the CNC machine. And the horizontal plywood sheets were manually cut by table saw and lightly treated with the waterproof treatment to prevent water pooling under the limestone panels. Once we fabricated each group of assembly pieces, we try to dry fit in the large lecture hall in the public building as much as possible before moving them onto the site. When we located all the ground structure pieces on the site, we worked most of the time connecting the groups of assembly lines and also leveling the pieces on the ground, which are not quite so flat. And for the fabrication of the limestone parts, Bybee Stone Company, located in Lettsville, was our community partner for the limestone fabrication process. With their long history of running in the industry, we could have utilized their more than 100 years of their old antique gang saw in this photo to produce the horizontal cut panels. This machine actually allows cutting constant thickness to the panel as we want, and also we can add groove textures called chasson, as shown in the photos here on the right, which is the installation photo. For the engraved vertical panels and on the ground level, and also the panels for the vertical markers, we utilized their large-scale CNC machine. And we were able to dry fit our 3D printed metal bracket as seen in this photo on site. Bybee Stone also helped us to operate the forklift to move all the pieces on site. And the individual pallet of stone piles came with the tag number list, and we could locate the stone pieces at the correct location as we designed. For the fabrication of the vertical marker, we partnered with Ignition Arts of Indianapolis. The particular position of metal posts is designed to indicate the sun angle of summer and winter solstices in Columbus. And within that position, our ongoing design of a limestone modular panel system was utilized to enhance the direction of the angle as a signage. The metal structure is designed and also prefabricated a unistrut system and also American Earth anchor systems, anchor screws for the foundation. The panels were secured by 3D printed metal brackets that is developed with engineers and technicians of an additive manufacturer team of the Cummins Tech Center, which I'll talk a little more in a separate section in the following section discussing our collaborative process. As I said earlier, Ignition Arts did most of the fabrication installation for the vertical marker, and the pieces were assembled, prefabricated their shop in Indy first and installed on site. The challenging part of the installation process turned out to be propping the vertical post straight up in relation to the horizontal frames. And we had to really calibrate it carefully back and forth many times to write it up. And in terms of a 3D printed metal bracket that I mentioned, they were developed at the Cummins Tech Center located in the building designed by Harry Wiz in Columbus. We hugely thank to the team of the Tech Center, John Robb, Chigozie, Obidigabo, Devin Hunter, and also Jason Hamilton for their time and involvement in this process. The 3D printed metal bracket in our design, it was to reveal hidden metal bracket of a typical veneer masonry construction method. And it also meant to serve as both ornamental and functional parts of the design system. The design can be applied externally as a rain screen system. We also think it's possible to internally as a decorative accent wall. And for the design process through the several iterations, we had to go through the several design iteration studies, and we eventually developed a bracket that design that can be printed and assembled in pieces, like 5 pieces, by simple sliding mechanism, and which helped to prevent a weak structural point and printing capacity more efficiently. So the tolerance of the sliding mechanism was also tested and tested out closely, and all the brackets used in the LaWaSo ground were packed in two batches of a stainless steel metal printer at the center. And the 4 ends of the 3D printed metal brackets were machinery threaded after 3D printed process has done and completed, and which works with a common M6 diameter nuts and washers about quarter inch diameter. After Ignition Arts installed the structural metal posts and frames, we installed the limestone panels with the 3D printed metal brackets on the 60-foot boom lift ourselves. And lastly, we'd like to talk about synthetic turf fabrication and installation process, which was supported by Sinnon, Indiana, branch office of the Sinnon Group, which is a national scale of the synthetic turf manufacturer in America. Prior to the installation process of the turf, we had to prepare the groundwork, filling with the number 8 gravels. We ordered about 17 tons of gravel, and all the egg crate mounted forms were quickly filled with the help of Vince Rubio and his crew of the City of Columbus Department of Public Works. We truly, truly appreciate their involvement at this stage. And of course, we had to use manual labor for smaller parts of the groundwork. And we thank so much to volunteers who helped us, Melissa Niedermeyer, Stephanie Gorham, and Dane Wallace for your time and effort to make this happen. Thank you so much. Since we were doing this for our, doing the most of the prep work of the ground condition under the turf ourselves, we wanted to clearly communicate with the Sinnon, Indiana about the construction method and how we think the turf can be installed on the top. And with their expertise and help, we were able to come up with a simple solution for the unusual installation condition using nailer board and simple ground pins and nails. We also were able to provide a cut template to make sure the direction of the turf grass to match throughout the installation. Actually, on the site, while they're installing the turf using this template, Sinnon installers could position the right cuts at the right direction and right location fairly quickly. Sinnon also brought more sand materials to make sure the groundwork looks as smooth as possible. And we really truly appreciate their professionalism and expertise. Thank you so much, Anastasia, Lorraine, and Everett, and other installation crews of Sinnon, Indiana throughout the process. And thank you so much for listening for this presentation. I think this is the end of it. I hope this helped for you to understand our design and fabrication and collaborative process among our partners and collaborators. And lastly, thank you, Mimi, Iker, and Janice, Richard, and all the members of Exhibit Columbus, Ben, Bethany, Jamie, and especially Todd for all the process and final installation photos. Thank you so much.